So you've probably heard of game theory. It's this incredibly powerful framework that promises us a mathematical way to figure out how rational people are going to act. It's used in everything from economics to biology. But what happens when that perfect, clean math smacks right into the messy reality of human choice? Well, that's the paradox we're going to dig into today.
And this is really the core question, isn't it? We're often told that a logical system, like game theory, can give us these definitive answers about what people are going to do. But as we're about to see, that belief, well, it might just be the biggest myth of them all.
Okay, so to really get why game theory is so appealing, we have to start with a classic scenario where the logic, it seems absolutely flawless. It all kicks off with two prisoners, stuck in two separate rooms, and they're facing a really tough choice.
And here it is, the famous prisoner's dilemma. So, two partners in crime get caught. They're put in separate rooms so they can't communicate at all. The prosecutor goes to each one and offers them a deal. As you can see right here in this grid, their fate, how many years they're going to serve, doesn't just depend on their own choice to confess or deny. It depends on what their partner does too.
All right, let's put ourselves in prisoner one's shoes for a second and just follow the pure logic. He's thinking, okay, if my partner confesses, my best move is to confess too. 8 years is way better than 10. Then he thinks about the other possibility. And what if my partner stays quiet? I'm still better off confessing because then I get to walk free. So no matter what the other guy does, confessing is his best move. It's his dominant strategy.
And here is the crazy part. Since both prisoners are perfectly rational, they both follow that exact same logic. They both confess. And this is the paradox at the heart of it all. By each making the absolute best, most logical choice for themselves, they end up in a situation, 8 years in jail each, that is so much worse than if they had just trusted each other and stayed quiet.
So this outcome, where they both confess, it actually has a special name, a Nash Equilibrium. It's basically a stable state. Given what the other person chose, you have no reason to change your own choice. Nobody can do better by acting alone. And on the surface, this seems like a super powerful predictive tool. But what if the most stable outcome isn't actually the best one?
And that question brings us to our next game, which really starts to pull apart that simple predictive power we just saw. Because in some games, the so-called rational choice, well, it gets a lot murkier. This one's called the Stag Hunt. Imagine two hunters. They can work together to hunt a giant stag, which would be a massive feast for both of them. Or they can just go it alone and each catch a small hare, a guaranteed meal, but a much smaller one. But here's the catch. If you try to hunt the stag by yourself, you fail, and you get absolutely nothing.
Now, check this out. Unlike the prisoner's dilemma, this game actually has two stable outcomes, two Nash equilibria. Both hunters going for the stag is one, and both hunters going for the hare is the other. The stag hunt, that gives the best possible reward for everyone. In game theory speak, we call that Pareto dominant. But the hare hunt is the safer bet. It's risk dominant because, you're guaranteed to at least eat something.
And this brings a really powerful human element into the puzzle that wasn't there before: trust. To go for that big prize, the stag, you have to completely trust that your partner is going to do the same thing. If you have even a tiny bit of doubt, the quote-unquote rational choice might just be to play it safe and go for the hare. And all of a sudden, pure math can't give us one single clear answer.
So this leaves us with a really tricky question. What does being rational even mean here? Is it about maximizing your potential reward, or is it about minimizing your potential loss? Game theory, all by itself, can't help us decide between these two stable outcomes.
And this whole problem of having multiple answers, it's not some rare exception. It's actually a fundamental challenge to the whole idea of game theory as a perfect predictor. Let's take an even simpler everyday example. Okay, imagine two drivers heading straight for each other on a narrow road. To avoid a crash, they have to coordinate. The outcomes are pretty simple. If they both veer to their left, they're safe. If they both veer to the right, they're also safe. But if they pick different directions, disaster.
So, once again, we have two Nash equilibria, and the theory correctly points out these stable outcomes. But then it offers exactly zero guidance on which one the driver should actually choose. In a split-second decision like that, the formal theory is totally unhelpful.
So how do we solve this in reality? I mean, we do it all the time. We use what the economist Thomas Schelling called a focal point. In a country where people drive on the right side of the road, veering right isn't just one of two options. It becomes the obvious default choice that everyone expects everyone else to make. And here is the real kicker. That solution, the focal point, It doesn't come from the numbers in the table. It comes from shared culture, habits, and psychology. These are all things that exist completely outside the formal mathematical structure of the game.
And that leads us to the most profound critique of game theory as a prediction machine. We're not just talking about some tricky games anymore. We're talking about a fundamental gap between the theory itself and the real world.
Here's the key idea you have to grasp. Game theory, in its purest form, is like an architect's blueprint. It's a perfectly logical, self-contained system of lines and angles. But a blueprint alone can't build a house, right? You need to connect it to the real world. You have to decide what those lines represent in terms of wood and nails and concrete.
These connections are what we call bridge principles. They are the assumptions we absolutely have to make to link the abstract model of a game to actual, real-life human behavior. Without them, the theory is just, well, it's just numbers on a page.
And these bridge principles, they basically come in two main flavors. First, you have to make a big assumption about what people actually care about. Is it just about the money, or do they also value things like fairness or their reputation, or maybe just not looking foolish? Second, you need some way to reliably measure those values before the game even starts.
But this is the fatal flaw, and this quote from our source material just nails it. These principles aren't some systematic part of the theory. They are chosen ad hoc, which is a fancy way of saying they're made up for a particular purpose on a case-by-case basis.
And this just blows up the whole idea of prediction. Think about it. If you can pick and choose your assumptions about what people value after you've already seen what they did, you can always create a game theory model that explains their behavior. But that's not prediction. That's just explaining things in reverse.
So if game theory fails as a perfect prediction engine, where does that leave us? Was this whole journey for nothing? Absolutely not. We just need to completely reframe what it's for.
So what is its true value? Look, it's not about giving us the answers. It's about forcing us to ask better questions. It gives us a language, a structure to think critically about strategy. It makes us define exactly what players value, how much they trust each other, and what hidden social rules are really running the show. Game theory might not be a crystal ball that shows us the future, but it is an absolutely unparalleled tool for sharpening the way we think about it.